So if you've spent any time at all in Web3, you know the reality. It's pretty messy, right? You've got dozens of these independent blockchain networks, Ethereum, Polygon, Cosmos, Avalanche, you name it. But they're all kind of siloed, speaking different languages, trying to build an app that works seamlessly across them using assets and logic from everywhere. It's just, well, it's a nightmare. Fragmented liquidity, tons of complexity. So today we're diving deep into something trying to fix this mess, chain abstraction and interoperability. And we're really focusing on one network that aims to be the backbone for this unified future, Axelar.
Yeah, our mission today is pretty straightforward. We're going to dissect Axelar's core tech, specifically general message passing, or GMP. We need to understand how it actually pulls off cross-chain computation. And crucially, we'll then put Axelar right next to its main competitors, Wormhole and LayerZero. So you can walk away with a really clear picture of, the whole competitive landscape.
Right, because if Web3 is ever going to be this global operating system people talk about, we absolutely need infrastructure that routes more than just tokens. It needs to handle full program logic. And Axelar's vision, well, it's building this internet of blockchains, kind of like an air traffic control system combined with a universal translator, right? Routing validation, communication, translating protocols.
Exactly. And to really grasp the scale of that ambition, you got to start at the foundation. See, unlike a lot of traditional bridges or messaging systems, which often kind of piggyback on the security of the chains they connect, Axelar is actually a layer 1 blockchain itself, built using the Cosmos SDK.
Okay, hold on. A layer 1 for interoperability. Why is that choice so important?
It's paramount. It means Axelar secures itself independently. It uses its own proof-of-stake consensus fueled by its native token, AXL. So it's an independent, programmable cross-chain layer. It's not just passing messages and relying on other system security. It is the security layer.
That L1 security model, that leads right into its architecture, doesn't it? The hub and spoke model. Because, like you said, a multi-chain future sounds like it could become this incredibly tangled web of connections between every single chain. How does hub and spoke actually simplify that structurally?
It creates a much cleaner setup. Think one-to-many. Axelar is a central hub. Every connected blockchain, the spokes, only needs one connection, straight to the hub. They don't need to build and maintain, a unique, complex bridge to every single other chain out there. That dramatically cuts down the complexity, both for developers building on it and for users interacting with it.
Okay, but wait a second. If everything has to go through this one central hub, doesn't that sound like a single point of failure? Which maybe a mesh network of direct bridges might avoid, at least in theory.
That's exactly the right question to ask. And Axelar tackles that risk through its security model and a containment strategy. Because the hub is an independent L1 secured by potentially thousands of its own validators, it's designed to be highly decentralized itself. But more importantly, the architecture acts as a kind of security bulkhead. Let's say there's a big problem on one spoke, like a vulnerability, or maybe an asset depegs badly on chain A. The hub can isolate that failure. It stops it from cascading and taking down the whole interconnected system.
Containment. Okay, that makes sense. Smart. Let's get under the hood then. How does this decentralized hub actually work? How does it monitor stuff and execute functions across chains?
Right. It boils down to 3 core technical pieces. First, at the network level, you've got the decentralized validator network. This is a dynamic, permissionless group of proof-of-stake validators. They run the core cross-chain gateway protocol, constantly reaching consensus. Second, there are the gateway smart contracts. Think of these as installations, little outposts, deployed on every single connected chain. The validators keep watch over these gateways for any outgoing transactions or messages. Once enough validators reach consensus on the validity of that message, they then collectively write the instruction to the gateway on the destination chain. And that triggers the execution of the function over there.
Ah, okay. So the validators are like the decentralized brain, the shared network that watches everything, verifies it, and then tells the destination chain what to do.
Precisely. And the third piece just makes it easier for developers. The APIs and SDKs. This is the application layer, the tools devs actually use. One really key tool here is Axelar Gas Services. It handles all the gas payment conversions automatically in the background. So for a developer, it feels much more like building on one single seamless chain, even though they're interacting across many.
Okay, that seamlessness is huge. And that brings us to general message passing, GMP. You said it facilitates secure computation. Computationally, how is GMP really different from, say, the simple token bridging most people are familiar with? Lock on one chain, mint on another.
Yeah, it's a fundamental difference. Traditional bridging is mostly financial logistics. Lock token X on chain A, mint a wrapped version, WX on chain B. That's about value transfer. GMP is Well, it's full stack communication. It lets an application send and receive basically any arbitrary data payload across chains. And that payload can contain function calls, complex data structures, or even a mix of program logic and assets together.
Any payload. Okay.
Fundamentally, what GMP does is securely synchronize the state between the different blockchain ecosystems. It allows a program running on one chain to actually trigger functions or update states on a completely different chain. That's the key to what we call programmable interoperability. It's not just moving value, it's executing logic.
That feels like the real paradigm shift. It lets you genuinely compose dApps, right? Like snapping together Lego bricks, taking functions from one chain and making them work with assets sitting on another chain. I like that phrase you used. Bringing the program to the asset.
Exactly. Let's take a concrete example. Collateralized lending. Imagine you have a valuable, maybe unique NFT locked on Ethereum, and you want to use that NFT as collateral for a loan in a DeFi app running on, say, Avalanche. With GMP, you don't necessarily have to bridge the actual NFT itself, which can be risky and complicated. The asset can stay put, securely lock on Ethereum. A secure cross-chain message, a function call via GMP, is sent to the Avalanche app. This message basically says, hey, this specific NFT on Ethereum is locked and reserved as collateral for this loan. The Avalanche app can then verify the state via Axelar and issue the loan.
Wait, just to push on that a bit, if the NFT stays on Ethereum, isn't the Avalanche app still relying on the state of that Ethereum asset? How is that fundamentally safer than bridging, say, a wrapped version? Doesn't it still introduce a dependency risk, even if it's not a direct asset risk?
That's a fair point. The security improvement comes primarily from Axelar's own L1 validator consensus, verifying that lockup event on Ethereum. It's secured by Axelar's economic stake, not just, say, a small multi-sig. And crucially, especially for NFTs, you avoid moving unique, non-fungible data across chains. Bridging a fungible token is one thing, value is value, but an NFT often has specific metadata, history, maybe even rights tied to its existence on Ethereum. GMP lets you interact with its state for collateral purposes without migrating the actual canonical asset itself, avoiding potential issues with provenance or fractured ownership records.
Okay, that makes sense. Maintaining the canonical source.
And this capability unlocks some really powerful use cases we're seeing emerge now. You mentioned protocols like Squid. They're enabling really complex one-click cross-chain swaps using GMP under the hood. Or look at Prime Protocol. They're using GMP to build these universal liquidity pools, allowing cross-margin trading by pooling collateral from basically any asset on any connected chain.
Yeah.
That's huge.
And it goes beyond finance too, right? Like even governance. I saw something about an integration with Filecoin, letting data DAOs manage their, massive data sets across different chains, using GMP for the state synchronization and the organizational logic needed. Pretty cool stuff. Okay, so we got the structure, the messaging system. Let's talk about the fuel and the security. We know that AXL token secures the network through proof of stake, but what are its specific sort of crucial roles? You mentioned 3.
Yeah, exactly. Beyond the obvious ones, staking for network security, where token holders stake AXL with that dynamic set of validators. There are 2 others. Second is governance. AXL holders get to vote on proposals, things like changing network parameters or approving upgrades, standard L1 stuff. And third is transaction fees. This is where the user experience really shines.
How so? Fees are usually a pain point.
Right, but here's the thing. Users only pay gas once, and they pay it in the source chain's native token. So if you start on Ethereum, you pay in ETH. If you start on Binance Chain, you pay in BNB and so on. In the background, Axelar's smart contracts automatically handle converting that source token into the AXL needed for the hub's operations, and also into the native gas token needed for the final execution on the destination chain. It totally abstracts away all that multi-token complexity for the end user. They don't need to hold AXL or the destination gas token.
Wow, okay. That seamless fee payment, paying once in the source token, that is a massive differentiator. That removes a huge friction point. Now, on security specifics, you mentioned they use some extra safeguards beyond just standard POS. What was that? Quadratic voting. What is that, and why should a user care?
Right, quadratic voting. It's a specific mechanism aimed at combating validator centralization. In typical proof of stake, a validator's voting power is usually directly proportional, linear, to how much stake they have. More stake, more power. Axelar uses quadratic voting specifically for transaction processing consensus. What this means is the number of votes a validator effectively gets is the square root of their total stake.
Square root, so it scales down the power of the big players.
Exactly. It dramatically reduces the effective voting weight of the very largest stakers compared to smaller ones. This helps counteract that tendency for power to concentrate in the hands of a few big players, which you often see in POS systems. So for the user, it means the consensus verifying their cross-chain messages is likely more decentralized and harder for any single large entity to unduly influence. It enhances the integrity. And they combine this with other measures too, like rate limits on message passing, regular key rotations for validators, and ongoing code audits. Security is layered.
That quadratic voting detail is a really vital nuance.
Okay, speaking of integrity and how we measure success. In Web3, everyone's obsessed with TVL, right? Total value locked. But Axelar seems to focus on a different metric. Why do they emphasize cross-chain transaction count more than TVL?
Yeah, that's a deliberate choice. Because GMP enables so much more than just asset bridging. Remember, it's computation, governance messages, general data transfer. TVL only really captures the value of assets currently locked or bridged through the system. That's important, sure, but it's a narrow view for a network like Axelar. Focusing on cross-chain transaction count gives a better picture of the network's actual utility. It reflects all the different ways the network is being used for full-stack communication. And the numbers are significant currently. They're reporting something like 1.823 million active cross-chain transactions processed, with a historical total volume around $8.62 billion. It shows broad usage beyond just park assets. Okay, that makes sense. Measuring activity, not just locked value. All right, let's zoom out then. Let's look at the whole playing field in this chain abstraction race. You've basically got three big names we keep hearing: Axelar, Wormhole, and LayerZero. And you mentioned their security models are quite different. That seems like the crucial comparison point.
Absolutely. The security model is fundamental.
Yeah.
So let's break it down. Axelar, as we've discussed, is the layer 1 hub. Security comes from its own large, dynamic proof-of-stake validator set secured by the AXL token. Runs its own full L1 consensus. It's built for general message passing that full stack computation, and it connects over 60 blockchains currently. Binance Research even noted recently that in a specific 30-day period they looked at, Axelar had a higher transaction count than its main rivals.
Okay, Axelar. L1 POS hub, GMP focus. Then there's Wormhole. How do I secure things?
Wormhole is positioned as a universal message passing protocol, often called an AMB, arbitrary message bridge. Its security relies on a much smaller permission set of 19 Guardian nodes. These are typically large, established staking entities or infrastructure providers. For a cross-chain message to be considered valid and relayed by Wormhole, it needs consensus from at least 2/3 of these Guardians, so 13 out of the 19 must sign off on it. It connects around 38 chains now and has processed a huge number of messages, historically over 1 billion, they say, with a total value transferred over $42 billion. So massive volume, different security trust assumption.
19 Guardians needing 13 signatures.
Okay.
And finally, LayerZero. Their approach is different again, splitting the verification work.
Right. LayerZero calls itself a full-chain interoperability protocol, really focused on lightweight message delivery. Their core technical piece is the ultra-light node, or ULN. It's designed to be very efficient to deploy on different chains. But the key security mechanism relies on splitting the validation responsibility between two independent external roles. First, you have an oracle currently. Chainlink is the main one they use. The oracle's job is just to publish the block header of the source chain transaction to the destination chain. Second, you have a separate entity called the relayer. The relayer's job is to provide the actual proof of that transaction corresponding to the block header.
Okay, so the oracle provides the header, the relayer provides the proof, the security relies on them being independent, right? The theory is that they can't collude.
That's the core idea.
But does relying on two specific external parties, the oracle and the relayer, just shift the trust assumptions? Does it introduce a potential coordination risk or maybe centralized risk onto whoever is chosen as the oracle or the default relayer?
It definitely shifts the risk profile, and that's crucial for users and developers to understand. LayerZero's security model holds if and only if the chosen oracle and relayer do not collude. They operate under the assumption that these two entities won't trust each other and won't work together nefariously. LayerZero argues this split, combined with their efficient ULN architecture, makes their protocol incredibly lightweight and easy to integrate. And that efficiency is likely why they've seen rapid adoption, connecting over 50 blockchains and reporting over $50 billion in total value transferred. It's a different set of trade-offs.
Yeah, different trust assumptions, different potential failure modes, and all three, Axelar, Wormhole, LayerZero, have attracted huge valuations and significant institutional money. It underscores how critical this interoperability infrastructure is seen to be. But as some sources rightly point out, this whole chain abstraction space, just like the cross-chain bridges that came before, is still a really high-value target for exploits. There are inherent security risks and ongoing questions about potential centralization points in these early stages, regardless of which specific model they use.
Absolutely. It's a constant cat and mouse game of Web3 security, isn't it? Always evolving. Looking forward for Axelar, though, the clear focus seems to be on making cross-chain development not just possible, but maybe even easier than building on a single chain. And that's where the Axelar Virtual Machine, or AVM, really comes into play.
The AVM, powered by CosmWasm, I read, it promises this idea of build once, run everywhere. For developers listening, how does this AVM actually simplify things? What does it let them do?
It's about orchestrating logic across chains. The AVM powers two key product suites emerging now. One is the Interchain Token Service, ITS. This lets developers issue tokens, maybe a stablecoin, maybe a governance token that inherently maintain their fungibility and custom features across many different chains simultaneously, right from the start. No complex bridging needed for the token itself. The second major product powered by the AVM is Interchain Maestro. This one gets compared a lot to Kubernetes for Web3.
Okay, Kubernetes for Web3. For listeners maybe not deep in the DevOps world, what does that mean? What kind of problem does Kubernetes solve in traditional tech that Maestro is trying to solve now for decentralized apps?
Right, so Kubernetes in the cloud world is all about managing complexity. It handles deploying applications, scaling them up or down automatically, managing updates, and generally orchestrating how software runs across lots of different servers or environments. Interchain Maestro aims to do something very similar, but for dApps across multiple blockchains. It helps developers manage where their different smart contract components live, how they talk to each other across chains, how upgrades are rolled out consistently. Essentially, it abstracts away a ton of the logistical nightmare involved in deploying and maintaining an application that needs to operate across, say, 10 different blockchain environments.
Okay, automating the multi-chain deployment and management headache. That sounds incredibly useful for developers. What else is on their roadmap for, say, 2024, 2025? Any big milestones we should be watching?
Well, one potentially very significant thing is a governance proposal currently under discussion, the gas fee burn. If this gets approved and implemented, instead of AXL gas fees being paid out to stakers and validators, they'd be sent to a burn address and permanently removed from circulation. If Axelar maintains or grows its transaction volume, this could potentially create a strong deflationary pressure on the AXL token over time.
Interesting. And deflationary tokenomics are always popular. And are they expanding their reach beyond just the EVM-compatible chains?
Well, absolutely. That's a major push. They have plans for significant integrations to bring non-EVM giants into the Axelar network. We're talking about chains like Solana, Stellar, and also the move-based chains like Aptos and Sui. Connecting these ecosystems is a big priority. And we're already seeing progress on partnerships. For instance, their integration with the upcoming XRP Ledger EVM sidechain is notable. And related to that, the launch of MXRP, which is a yield-bearing liquid stake token, derived from that integration, leveraging Axelar's infrastructure. So if we were to kind of synthesize this whole deep dive, Axelar made a big bet early on that the future is multi-chain and needs robust, secure, programmable interoperability. Their decision to build as a sovereign layer 1, secured by POS, and to focus on general message passing for full-stack communication seems to be paying off. They're positioning themselves not just as a bridge, but as essential infrastructure, enabling developers to build truly cross-chain native applications with the AVM and related tools.
Yeah, it really feels like you now have a solid framework for evaluating these key players in the chain abstraction space. You can really differentiate them based on those core security models, Axelar's L1 POS hub, Wormhole's permissioned Guardian set, LayerZero's dual Oracle relayer mechanism. And also based on their core messaging capabilities, Axelar's focus on GMP for computation versus perhaps more message-oriented approaches elsewhere. Plus, you can track their development priorities, like Axelar's AVM push. But here's the big question I want to leave you with, something to really mull over. If general message passing truly matures, if it really allows sophisticated computation and program logic to move freely, meeting assets wherever they happen to live, does the whole concept of an application having a single home chain eventually just dissolve? And if that location dependency fades away, what kinds of entirely new, truly decentralized, chain-agnostic applications might finally become possible? What opportunities does that ultimate freedom unlock?